Moving on to our second lesson, we are going to look at transforming our data. And so again, kind of the ways we can do that is like adding, subtracting, multiplying, and then we don't usually describe it as dividing, but multiplying by like 1/4 is the same as dividing by 4. So we're going to look at those types of things. Now, when a constant is added to every value, so again, adding 4 or subtracting 2, your mean, median, and mode of the new data set can be obtained by just adding whatever that constant was to each mean, median, and mode. So if you already know what the mean is and every single number gets added 4 to it, well, the mean is just going to have to add 4 more. You're going to, whatever the mean previously was, just add 4 more. So that works for mean, median, and mode. Now, range and standard deviation stay the same. So again, if I thought about it, my range was from 2 to 10. That's a range of 8. And I add 4. Now my range is from 6 to 14, but it's still a difference of 8. So if we look at this example 1, the data below shows the weight in pounds on Earth of 8 astronauts without their spacesuits. A spacesuit weighs 250 pounds on Earth. Find the mean, median, mode, and range of the standard deviations of the weights without their spacesuits and with their spacesuits. So they went through and calculated the weights without the suits. The mean was 158, the median was 158, the mode was 160, the range and the standard deviation. Now, if they add that additional 250 pounds on Earth, the average, again, instead of recalculating the mean, instead of recalculating the mode and the median, they just added 250 to what they previously had. So these, again, this is the weight on Earth is just adding 250. The range and the standard deviation do not change. Now, it's similar, but a little bit different when we multiply by a constant. So when each value of the data set is multiplied, the new mean, median, mode, range, and standard deviation can be found by multiplying each statistic. So this time, the range and standard deviation is going to change. So if we look at this example, the data set below gives the winning distance in meters in the men's Olympic triple jumps from 1964 to 2004. Find the mean, median, mode, range, and standard deviation of the distances of the meters in feet. So again, 1 meter is approximately 3.28 feet. So we're going to multiply. First, we're going to calculate the mean, the median, the mode, the range, and the standard deviation. So that's the column on the left here. Here's my mean, median, mode, standard deviation. And then what we do to find after we want to get our answer in feet, again, we're multiplying everything by 3.28. So we calculated our mean and then we multiplied it and got a new answer. We calculated, so the differences between multiplying by a constant is that it affects all parts of the data. Rather than where we just added, we did not change our range and our standard deviation.